My name is Neil Daswani. I am an engineer here at Google, and today I am particularly proud to be introducing our speaker, Sid Stamm. He's interning here at Google. His advisor at Indiana University is Marcus Jacobson. In a very short time, he's made a variety of contributions. He has contributed to a book that his advisor wrote. He has a paper on click fraud coming out at Usenix Security. He's had previous publications at the World Wide Web conference. So we're very lucky to have him. He's going to be talking about drive-by farming today. In this talk, it would be preferable, actually it would be required, that you do not ask any Google-sensitive questions, as the talk will be made available publicly on Google Video. But without any further ado, Sid Stamm, drive-by farming.
Thank you. Thanks for the more than generous introduction. I'm not used to that. Being a lowly grad student, I often get introduced as, this is Marcus's student, Sid. So having a little bit extra after my name was pretty nice. Anyway, I'm here today to talk about this drive-by farming attack that maybe some of you have heard about or read about, or you're just interested in the name because it sounds like some guys with guns driving past a farm. But I also want to talk about some other related types of web application, what I'm calling bummers. They're not really exploits for web applications. They're more of just confusing someone who's using the web and doesn't really know what's going on. So I'm going to talk a little bit first about identity theft, because that motivates the drive-by farming attack in its entirety, since this attack is all about stealing people's information. And then I'm going to go on and describe how technology, especially web technology, can be abused to do things like drive-by farming. And then I'll show you exactly what drive-by farming is, how it works. It's really not that complex, but it's nasty. And then we'll go from there. Throughout this talk, if anybody wants to add comments or anything, just go right ahead. Let me know. I'll answer questions as we go along. It's not really a formal discussion. I'd like to have a little bit of participation with you guys, especially when we get to the countermeasures part, where we're trying to stop stuff like this, because it's not an easy solution. So identity theft comes in many forms, and online right now, the most popular form of identity theft is phishing. People will send out emails saying, hi, I'm your bank. In this case, I got this email from Fifth Third Bank, who is my bank. And it says, we're performing some software upgrades, and you need to click here and confirm your user ID and password. So it looks a little shady to me because they never asked for my password. But what's even better is when I click this link, I go to a website that's like freemp3s.com/something. But the phishing emails go out to tons and tons of people, and a lot of people will fall victim to this, because this looks like a legitimate email from my bank. It looks very good. Unless you look at the text that's hidden down at the bottom, where it says things like, follow these, the cycle would start again, Aylesbury beseech, well, we'll have to. OK, so this is spam. And this is how it's trying to get around the spam filters, which real bank emails don't. So that's kind of ironic. But anyway, you get an email like this. It takes you to a web page. This is a different organization, but this is a phishing web page where they're asking for my full name, my ID, my password, my credit card number, its expiration date, my ATM's PIN, my email. I've seen others that go on, your social security number, your passport number, your date of birth, your mother's maiden name, et cetera, et cetera. And this is identity theft at its finest. This is taking it right from the source. And there's other ways to steal people's identity. Well, actually, one funny thing about this page itself, it was copied from a page that looked almost exactly like this, minus these last many fields. But this page, when shrunk, looked like crap, looked absolutely terrible. So apparently they didn't put enough effort in to make it resizable. But another type of identity theft stems from crimeware. Crimeware is like evil software that does nasty things, unexpected things on people's machines. And then whoever made the crimeware benefits, financially usually. For example, session hijackers. These are things that affect your browser. When you're browsing the web, they look for URLs, and when a URL comes up that the hijacker is interested in, it redirects you to an evil copy of that website instead of a legitimate one. Or session scrapers, which will skim off passwords as you enter them in legitimate sites. This includes data stealers, rootkits. I don't really want to get into everything that crimeware is. This is covered very well in the past. But this doesn't include things like adware that just pops up ads, or like a code red worm or something like that. These aren't really crimeware because they're not stealing your information and benefiting like organized crime would. If you're interested in crimeware, for more information, you can see antiphishing.org. They have lots of information. And then we get into pharming. Pharming has many definitions. One of the definitions just happens to be very similar to phishing, thus the PH, I suppose. And the basic idea of pharming is you manipulate DNS records in order to bring people's traffic to you instead of to legitimate servers. So I will somehow, I don't know, manipulate DNS records so that everybody who types in securebank.com ends up at my copy of the website instead of the real secure bank. This is sufficiently harder than actually phishing, because you're not just sending out emails, erecting a website at some random place, and hoping people are stupid. Instead, you're actually screwing with the infrastructure. So this is a lot nastier because people will look in their URL bar when they're at a phishing site, and they'll see securebank.com. And if they're really unlucky, they'll have a secure connection to securebank.com, and no one's the wiser. Pharming isn't as prevalent as phishing, but it has a much higher yield. More people will fall victim to this because a lot of the hints that say you're being phished just aren't there. There's many ways to do this. Yes?
Is there any data on how much this has actually happened?
Is there any data on how much pharming has happened? This is hard to collect because people don't notice it. I don't know of any good hard data. But anyway, this is traditionally done in many low-level ways, such as with IP prefix hijacking, which is hard. Well, it's definitely harder than this drive-by pharming technique that I'm going to talk about. So all of this identity theft stuff is somewhat complex, but it gets a lot easier when we have technologies that are widely used and easily abused, like browsers. Everybody uses a web browser. Well, everybody on the internet uses a web browser. Here are three popular ones. We've got Safari and Internet Explorer and Firefox. There are others, Opera, tons of mobile browsers. But they're all slightly different. They all implement standards differently. Sometimes there aren't standards to implement, so they implement technologies differently. They're all complex. They're all feature-rich, except arguably Lynx is not very complex or feature-rich. But they have things like cascading style sheets, JavaScript, plugins like ActiveX, signed applets, Flash. All of these complex little pieces of the browser make it a really nasty beast to deal with when it comes to safety, security, and privacy. So, for example, you can make an ActiveX control or a signed Java or unsigned Java applet that will detect your or the host's internal IP address. So you're on the internet with your computer. You're behind a NAT firewall, so nobody in the outside world can see your IP. But they can serve you a Java applet that will detect your IP and send it home. This is an example of something that shouldn't be able to be done, but it is. So let's talk about some other things we can do with browsers. First, I'd like to plug a project I did a while ago, because I think this is a cool project. Browser history snooping. There's a lot of different ways to get somebody's web browsing history without their permission. None of them are really elegant. Some of them are platform dependent. This method that we developed uses cascading style sheets and HTML, nothing else, and it determines who you use for banking. The gist of this is it goes down a long list of URLs, and based on whether or not your browser's visited them, your browser sends a note back to our server. And so we can see which URLs of this list you've visited. And then we can tell you, for example, you've been to Bank of America, so we can conclude that you've banked with Bank of America. That's kind of a leap of faith, just because you've been to the website that you bank with them. But we can check to see if you've been to bankofamerica.com/myaccount/logout. And then we can know that that computer, at least that browser, somebody who uses it banks with Bank of America. This isn't a vulnerability. This is an abuse of simple features and standards that are commonly used. You want links to look different based on whether you visited them or not. So if you have a long list, you can see some are purple, some are blue. You've all seen that. That's useful. It's incredibly useful. You also want to be able to load, using cascading style sheets, you want to be able to load images from remote servers. So you can set the background of something, or so you can do on mouse over, change the background to this image. That's all this uses. Anyway, so we can go on and on about this. If you want to try it on yourself, you can go to browser-recon.info and see if you're vulnerable. And send it to your friends so we can see if they're vulnerable. Now, this is the beast that everybody's talking about around here, is cross-site scripting. Cross-site scripting is mean, but necessary, right? I want to be able to embed on my web page a script from google.com that tracks the people who visit my page so that I can go to Google's analytics setup, big construct of amazing stuff. If you haven't visited it, go there, and track my users using the Google Analytics interface. In order to do this, I have to do cross-site scripting. And now, it's not always called that. I mean, this looks like cross-site scripting attacks. You know, it's evil. The thing is, I'm embedding a script from a different website onto mine. This time, it's intentional, so it's not an attack, per se. But if somebody's able to embed a script on my site without my permission, then it's an attack. If you can put a script on somebody's website, you can do a lot of nasty things. So this is hot research right now. The gray and black hat hacking communities are really interested in finding cross-site scripting vulnerabilities everywhere. If you come across any web application security blogs, you'll probably see a ton of this in there. Ooh, I found this one, I found this one. They pop up all over. Most of them don't have huge data loss results, but they could if somebody really wanted to take over a website. I like to say that right now hackers are having a cross-site scripting party, and it will be going to cross-site request forgeries next. What this is, it's like the evil cousin of cross-site scripting. Basically what happens is, on my site, which you may not trust, I cause a request to go to a third party's site without your knowledge. For example, here's a web page you can go to if you want, netflixcsrf.html. If you go to this website and you're logged into Netflix, it will cause 4 requests that add 4 movies to your queue. You don't see any of this. All it does is I have a blurb that says these movies have been added to your queue. Click here to check. It also attempts to add me as your friend on Netflix so I can see what movies you've watched. I'm not sure if that works because nobody really knows about this site yet. We'll find out. The basic idea is there's some confused deputy. Your browser is making requests on your behalf, and it's doing things without your permission. And this is harder to accomplish because instead of putting untrusted script on a trusted website, which was cross-site scripting, you're now putting somewhat trusted URLs onto an untrusted website. And you have to lure people there. If you combine these two, you can do a lot of nasty stuff. So anyway, check this out if you're interested. Cross-site request forgery is mostly what I'm going to talk about today. One thing you can do with cross-site request forgeries is scan a network, see which hosts are alive. So say this computer right here goes to the devil web server and requests a web page. The web page is transferred onto, we'll call this the victim's browser, and the victim's browser then checks a whole bunch of URLs to see if they're alive. 192.168.0.1, 192.168.0.2. And there's a trick you can use with JavaScript in order to catch errors to see which of the hosts that you tested were alive. Now, this is a great scanning technique because given a starting IP, you can scan an entire subnet and find out where the router is. Most home networks only have a few computers and a router. Yes?
When you say alive, you mean is running a web server?
Yes, yeah. When I say alive, I mean is running a service on the port that's being scanned. Most often, that's port 80 or a web server. Most routers run a web server. Most home wireless networking routers definitely run a web server. So this is where it's really interesting. If I can write that applet that I told you about before, that ActiveX control, that will detect this computer's IP, some local non-public IP, I can then enumerate through other IPs on the same subnet and see which one is the router. So here we've done internal network detection and also internal network detection of the router. So not only do I know how to get at the router, but I know how to get at the router from the inside. And this is important for manipulating settings. So why does this matter? If you're scanning a host network, there may be printers there you can compromise. There may be all sorts of things. I'm going to concentrate on the router because I think this is the easiest to compromise and has the most dire consequences. So here's how it works. This host scanning, here's some code. If you really want to know what it does, it's a for loop that adds HTML entities onto a web page. And as it adds them, the HTML source attribute in these tags is accessed. It's adding a whole lot of script references saying, access the script at this IP, access the script at this IP. And of course, there's not going to be a script there. But we're going to get one of two errors back. Either the error is going to say, timed out, could not find host, or the error is going to say, that's not a script. If it says that's not a script, the host is alive, and it's probably serving web pages. So here's a little abuse of standard JavaScript. Now, this can be fine-tuned by first detecting the IP. You can scan as many subnets as you want. And this can all be done in the background. And the results can be sent back to the server who's hosting this script. Now, some people disable JavaScript. Not many, but some people do. And so here's a way to do it without JavaScript. You serve up a lot of these. You have an alternating sequence of image and link tags. The link tags serve as a barrier to say, stop rendering stuff until everything up to now is complete. Right? Well, everything up to the link tag is complete. So what happens is the image gets requested. And while you're waiting for the timeout, this link gets requested to this server. After a duration that your server is set to allow, you send back a result to this link tag, and then it goes on to the next image. And you can use this to kind of infer which hosts are alive, based on which of these images got loaded, et cetera. Anyway, this was not my work, but you can find it at a URL that's really tiny here, or you can ask me for the URL after the show, or look for JavaScript-free host scanning. Yes? So how would this respond to browsers that prefetch images? This is totally implementation-based. This relies on the fact that when the browser renders sequentially from the top to the bottom. This relies on that. It also relies on the fact that when a link tag is encountered, that must be rendered now before anything else can go on after it. If that changes, and there's forward fetching of images not interlaced with these link tags, then this won't work. But then, of course, go back to this. Most people use JavaScript. Anyway, so host scanning is mostly unnecessary, we'll find, for drive-by farming. But you can use this to find where the router is if you really want. So let's talk about, we've talked about the browser problems. Let's talk about router problems. I don't have anything against Linksys, but they have lots of nice images on their website that I could use. So here's some problems with browsers. First of all, a lot of browsers have a web interface. This is my first gripe. Routers have a web interface for administration. Arguably, they shouldn't. Arguably, there should be some other completely separate way of administering your home router that has nothing to do with a web browser, because web browsers are complex and they can be attacked, et cetera, et cetera. Yeah, OK, so this is the lesson that I'm trying to I don't know, preach, if you will. Here's why. A lot of routers are thrown together sloppily and have very generic code on them, so that any form submitted on the router that may be in post-submission format can also be submitted as a GET request. This means you don't need a form on a page and a submit button to get it to work. You can simply make a URL and cause a cross-site request forgery. So no person has to be present to submit settings to this router. Also, default passwords are very, very common. Not many people actually change the administrator's password when they get the router home. You all probably do, because you're interested in this type of security. So I'm preaching to the choir here. But a lot of people don't. They take the router out of the box. They plug it in. It works, so they say, I'm not screwing with it. it's a good philosophy. You have this black box that magically gets you on the internet. Okay. But in this case, it's not a good idea, right? Because default passwords, since they're the same across many, many, many routers, they can be guessed quite easily. Now, additionally, this is less common, but a lot of browsers will serve images without requiring any sort of authentication. So if you request an image off of certain models of browsers without ever authenticating to the, or certain models of routers, without authenticating to the router, it'll serve it to you. As soon as you request a web page, though, not an image, it'll require you to authenticate. That's strange behavior to me. I would think that everything would require the authentication on a router, and it seems to me that would be the simplest policy. But in practice, this isn't always so. And lastly, all these routers behave quite predictably. They're mass-produced, they're mass-distributed, they're wildly popular. So there's a small set of configurations for username, password, URLs, and it can be guessed easily. And I'll talk about the details of doing that in a minute. But first, let's talk about what this drive-by farming attack that I've mentioned a few times actually is. What is it? OK. So here we have a setup where we have two DNS servers. We have an evil one and a good one. We have the internet service provider's gateway. All your traffic goes through your internet service provider somehow. And we have your home network, or the victim's home network, not yours, because you're not victims. So inside this home network, we consider it sovereign space. This is your house. Nobody should be able to invade this. The router is configurable only from the inside. If you try and configure it from the outside, it'll just, I don't know, give you the finger and say, go away. But in order to get at any web servers, like this is also a web server, you first have to find out where it is. You type in a name, say evil.com. Maybe not yet, maybe right now. Yes, you type in a name, evil.com, in your browser, and your browser asks your host, who asks your router, who asks your gateway, what the corresponding IP address is. And it goes to the ISP's DNS server, since that's what your router was told to use. And it comes all the way back, and it says, evil.com is 1.1.1.1. Not likely, but it fits on the slide. So now this is used in future browser requests to access things at evil.com. It just goes directly to the web server to get the data. And DNS is a convenience. If you're not familiar with it, talk to me afterwards. I'll fill you in. But the whole idea here is that lookup can't be trusted. Here's a different scenario. You have the DNS for evil.com. It's 1.1.1.1. And now you go to the website, evil.com. You send the request out. The request goes to your ISP. The ISP sends the request to the web server, comes all the way back to you, and there's some evil JavaScript on this web page. The evil JavaScript is inside your home network. It runs on your computer as you and reconfigures your router. At a high level, that's exactly what this attack does. It uses a cross-site request forgery to change settings on your router. Or on the victim's router, excuse me. None of you, because you're not victims. So then any future DNS lookups are routed to the other DNS server, because if the evil code is able to change the router, the evil code can say, use the evil DNS server. So now every single website is wherever this evil person wants it to be. Now you go to securebank.com, and it's really evilsecurebank.com. Or you go to google.com, and it sends you to Yahoo or something. It's whatever this attacker wants you to do. And this is why it's a problem. Most people won't notice. They see a web page that looks right. Unless, of course, you're redirected to Yahoo. Then maybe something's wrong. It's like, wait a minute, this is not right. But if he's only changing the values, the DNS lookup values, for banks, for example, and he has a good-looking copy of every bank sitting around somewhere, he can fool you, because you look at the URL bar, and it says, I'm at securebank.com. But you're really at evilsecurebank.com. It's just hiding the fact from you. Notice I haven't done anything low-level. No IP prefix hijacking. I haven't screwed with DNS caches. I haven't done anything that sounds scary. All I have done is this evil person is served up a little bit of JavaScript. first thing that JavaScript does is it takes these forms that are present in router configuration dialogues, and it changes them from a post submission to a GET submission. So now there's a URL that when that URL is accessed, the router changes its state. Now this is prearranged by the attacker. A good attacker is going to put maybe 300 of these on a web page that are going to cover a lot of different models, a lot of different firmware versions, all the most popular ones, of course, or at least the most popular with people who don't change their passwords. And so these 300 requests can go by silently, under the rug, while somebody's reading a paragraph or two of text. They look kind of like this, actually. And in fact, the browser thinks they're images, so it sees no problem with requesting an image from a third-party site, even if it's an internal IP address. In this case, I'm specifying administrator as an HTTP username and a blank as the password. Now, a lot of people have noticed this doesn't work in all browsers. It works in Firefox. Internet Explorer is going to forbid you from doing this. You can't specify a username. There's other ways to do this. You could do this in Flash. We'll let you specify a username. You could do this with an ActiveX control. But then it'll probably complain at you. The best thing you can do is rely on the user to have not closed their browser since they administered the password. But wait, these are the people who don't do administration, right? But maybe they use the same password for everything. So there's a lot of different things to take into consideration, but consider the fact that people are somewhat savvy, and they're using a browser that lets them do this, which is bad. So this happens. This request is sent off, and if it fails, it fails. No big deal. Your router's not going to lock you out from trying again, and one of the 300 is bound to work. Now you may be asking me, but aren't you going to get error dialogues saying, I couldn't load this image, I couldn't load this image, won't there be broken images on the page? A clever web programmer can hide all this, handling the errors just like I described you the host scanning before. They can make the images so small you don't see them, or hide them in an invisible frame. So in the end, really all this attack is, this drive-by farming attack, it's a long list of cross-site request forgeries. They can or cannot be generated by JavaScript. It doesn't matter. But the idea is I'm intelligently doing a dictionary attack on a router. And as I'm doing this, I'm finding one URL that's going to work for me from a fairly small set of URLs that I need to test. OK, so it's a simple attack. It sounds pretty realistic. What does this boil down to? Well, we did some number crunching. And about half of people use a default password on their router, which is interesting. This was an informal study. Obviously, you can't ask people if they have, excuse me, do you have bad security practices? Yes, I do. No. But you can do some tests to find out. If you're interested in this study, I can point you there. Also, it turns out that, 95% of people have JavaScript enabled in their browser. So we're estimating that about 48% of people could fall victim to this attack. That's millions and millions of routers. OK, does it work on all the routers? That's the next question you should be asking. Well, I tested it on these 3. These are just 3 models of routers. We know it works very well on these routers in Firefox, no problem. IE kind of works. But OK, it's got to work on more routers. Because there are lots of models of Netgear that have very similar configuration screens. There are lots of models of Linksys that have very similar configuration screens. There are lots of other models of routers that we didn't test. So luckily, after, well, we issued a press release with Symantec about this problem to get the word out, tell people to change their passwords. And interestingly enough, at about the same time, Cisco releases a security response kind of thing, saying, hey, everybody, there's this information about a Pharming attack. Yes, our routers are vulnerable. You should change your password. Here's a list of routers that are vulnerable. And they published a list of 77 routers. And this is really noble. They're trying to alert their users that you need to make sure your password is hard to guess. And they got all the crap for having vulnerable routers. Poor guys. I feel bad for them. And they're trying to help people protect themselves. So there are all sorts. Cisco announced 77. What about the other manufacturers? There are all sorts of routers out there vulnerable. And I see this as a huge problem because if you can compromise a lot of routers' DNS entries, you have the ability to also turn on other settings like remote administration, or you can upload new firmware onto the routers. And what does that lead to? Well, that leads to a router zombie network. Now we have all of these bots that are up all the time. Normally when you think about a bot network, you think about a bunch of compromised PCs of people who don't know anything about spyware, adware, bot networks, and viruses. And you think about PCs being controlled by one central location. Well, now we have routers that almost never go down, routers that are up when people are not home, routers that don't change their IPs ever. And if you can control those, well, there's something in that. And of course, it would be worse if these zombie routers actually sought out brains, right? Because then we'd have some doomsday scenario where routers are then turning into the attackers themselves and spamming people with emails saying, check out this cool website, where people click on the link and go to a compromised router, and then their router gets compromised. And then their router is now a new thing. And we have this viral spread. And this hasn't happened. I don't anticipate it happening anytime soon, but people are worried about an epidemic spread of things like this. And it should be taken seriously. When people have mismanaged routers, there is a possible doomsday scenario. And of course, a press release that says everybody's screwed, we need to protect everybody's routers is going to get a lot of publicity. And here's a little bit of what we learned from it. The top two show you a couple of newspaper headlines or electronic publication headlines because they probably weren't print newspapers. New drive-by attack taking over home routers. Change your router password now. It was somewhat sensationalized, but they got the message across. A lot of people were confused because of the name, drive-by Pharming. They're outside my house? No, they're not outside your house. This is not drive-by in the sense of a shooting. This is drive-by in a sense of drive-by infection. There are a lot of websites out there where you go to the website and it attempts to install a virus or malware or something on your computer. That's drive-by downloading. This is similar to that. Maybe we should have named it something else. Router hijacking, inside attacker. But most people got the idea. And my favorite responses came actually from Slashdot because people, I don't know if you're familiar with Slashdot, people post interesting replies to stories on Slashdot. Like, we'll chase our farmers with our flaming torches and pitchforks, with PHs placed appropriately. Or drive-by farming, this is the way you drive by farm. 1, drive by farm. 2, stop, park. 3, milk cows. 4, feed chickens. 5, slop pigs, stack hay. 7, profit. So debatably, the name was not the best name that we could have picked, but it got the message out, and we got publicity, so it worked. In fact, people liked the name so much that one unknown person registered drive-by-farming.com. There's nothing else here. There's no links. Some advertisements. They're probably making a little bit of money off of it. Probably hoping we wanted to buy it from them. But anyway, people know about it. That's what's important. Everybody should set a non-standard administration password on their router for now, while we work on a better solution to the problem. But this attack really isn't limited to routers. Right? There's other devices that use networks, like your home network. For example, there's this new product coming out, I think tomorrow, called the iPhone that has a web browser on it. Well, we don't know much about the iPhone yet, other than it will have a full browser, Web 2.0 widgets, and some mysterious operating system. OS 10, apparently, but on a phone, maybe. So the question is, can we attack the phone itself using the browser? And I don't know the answer, but I think the answer is probably yes. If Apple's done their good job with security and locking down Safari, which doesn't seem to be the case on Windows, they will have done a good job and protected the phone, and we'll have this instead of the evil attack horn phone from hell. Anyway, so the lesson is we need to be prepared for new stuff. We need to think about what we're doing. And so let's start by thinking about what types of countermeasures to drive-by pharming may exist. And here's where I would actually like some input. If anybody has an idea of how to stop this other than making people change their passwords, pipe in. Or raise your hand. Or I can prime you. I'll prime you. OK. Let's start with people. What can we do to people to make them not vulnerable to this? We can teach them. We can teach them about web security, and they can get a degree in it. And I'm a cynic of user education, because we're going to come up with new stuff, and we'll have to teach them about the new stuff. And at that point, teaching becomes full-time for everybody. We could teach them about DNS so they don't. Well, no, actually, that might not solve the problem. What else could we do? What could we do with people that would help solve this problem? Don't let them use computers. Yes, we have a Luddite in the audience. OK, well, let's move on. People are maybe not the solution. Oh, yes.
What if you don't have default passwords? What if you force the, when you log in, when you first bring up the router, you have to change the password?
Exactly. OK, what if you force them to set a password before the router's usable? We'll talk about that in a second. But let's talk about browsers. That's actually a great idea. What could we do with browsers to prevent this? Sign all web pages with keys that are trusted by a central authority? I don't like that idea. OK. I don't think browsers are the place to solve it either. Now we get to the router, right? What can we do with the router? We can make a non-standard password. We can make it hard to guess. I've heard a lot of suggestions. I've heard set the serial number to be the password of the router. So you need to actually be within proximity of the router to understand it. Debatably, that's not a good idea, because there may be ways to get the serial number. Also, the serial number is probably in a small space. It's also been suggested that people will need to set a password, just as you mentioned, before they can use the router for the internet. And I think if there were two companies selling routers, and one of them required this and the other one did not and allowed default passwords, everyone would buy the ones where you don't have to set a password, simply because when you bring it home, you plug it in, it works. But that would solve the problem if all routers did that. What else could we do? We could implement the administration console properly so it doesn't accept GET requests. Don't use HTTP to administer it. Apple does this with their wireless base stations. You need to use the special application or SNMP to administer it. So naturally, those routers are not vulnerable to this attack. It's also been suggested that a random password is made up, printed on a sticker, put on the router, and shipped to them. And that's the default password for the router. Interesting idea. So it boils down to something unpredictable. Yes?
To require post requests to solve the problem, because I can put a lot of forms in the web page too, right? And I can submit those forms by JavaScript.
Sure. So the question is, would disallowing GET requests on routers actually solve the problem? Maybe, probably not. Like you said, we could put a form on a web page, fool someone into filling out the values 10.231.4.6, or you can do other things to capture keystrokes and put them in an order. Or put a bunch of hidden fields with stuff you want and get them to click on a button. That would work too. Or you could assemble a post request in a Flash file and submit it to the router. Yeah, you're right. I don't think it would solve the problem, but it would definitely help. Yes?
Well, one way that wouldn't really work is you could add a CAPTCHA to the page so that I type in these letters, and then you just show that to the user, and they're like, oh, it's one of these things again. I'll just do it.
Yeah, so you answered your own question. You could add a CAPTCHA to all configuration submissions so that before this configuration is allowed on the router, it has to be backed up by some sort of second factor like a CAPTCHA. But people, yeah, they see CAPTCHAs all the time, like you mentioned, and we'll just fill it in. In fact, people will fill in CAPTCHAs so frequently that I'm sure spammers are using CAPTCHAs from other sites on their website to solve them for hacking purposes. But anyway, so maybe that's not solvable only on the router. Can it be solved on the internet service provider? Can we have the ISPs take care of this? We could have the ISPs disallow any DNS traffic except for the ones going to their servers. Their servers go down, their network goes down. That's not a good idea. Also, some people don't like their DNS servers that their service provider offers because it's not complete. So they use OpenDNS or something like that. But this is an idea. And if ISPs are interested in closing down pieces of their service, they're more than welcome to. But I don't think that's the problem. You can also block ports. You can do all sorts of crazy stuff if you're the ISP. But I think people will resist this if you start blocking things. I think they will tend to want their freedom and go to a different ISP. I think all of this really boils down to one word, boundaries. We need to understand all of these technologies and where they overlap. We need to understand the cross in boundaries, like a same origin policy that prohibits website A from talking to pages from website B. That's a good policy. We need to understand it better when we're implementing a browser, and we need to actually implement it clearly, distinctly, and properly. There's other policies that need to be understood as well. Access control. Why can my browser submit requests to my router? Doesn't seem like an easy technical solution, but we need to understand why my browser can submit requests for me. If we get this wrong, then context boundaries close down, and we end up with the mess that we have on the web right now. That's websites that can kind of talk to other websites in an unspecified kind of frenzy. And this leads to cross-site scripting. This leads to cross-site request forgeries. And this leads to abuses of technologies that everybody uses. And I mean, we see a lot of companies going the right step. Google's taking the right step. They're defining boundaries, especially with APIs, properly. Security is being taken very seriously here, especially with respect to cross-site scripting. And I think it's a start. But we need to keep track of this in everyday work and make sure that these boundaries aren't easily violated. That's all I have. Any residual questions? Yes?
So this drive-by stuff is, the fact that it's a wireless router is not really relevant, right?
Has nothing to do with it. They're just by far the most common. Drive-by farming can be pretty much accomplished on any router that's HTTP configurable. Oh, well, and not protected. Yes?
So for banks that use certificates and make their site HTTPS, you know, an attacker can always set up a site with HTTPS, but will they have to go to a CA to get, you know, a certificate for a site that kind of looks suspicious?
OK, so the question is, a lot of banks use certificates that are signed by a certificate authority, so that when you go to the website, the browser can authenticate the server. And if by farming someone is taken to an illegitimate version of the site where the certificate is not signed by the authority, does this still work? Will they really be fooled? And the answer to that question is not all that clear, because there are a bunch of different ways to implement a site. The first thing you can do is forbid HTTPS connections. Obviously, that will filter out a lot of people who only want to bank over HTTPS. Like, I would not go to that site. The second thing you can do, and a lot of websites actually encourage this use, is you can rely on a bad use of secure post. A lot of websites will provide a non-secure connection at first so they can load really quickly. And then it will post, when you submit your username and password, it will post to a secure web server. OK, so if that's the behavior on the bank, then somebody can spoof that and just never post to a secure web server. Another option is to provide an unsigned certificate. And arguably, people will accept anything you give them. So you will still be able to compromise a large number of accounts.
Well, how many people would even notice that they ended up at a non-HTTPS version of their bank website?
Right, so yeah, how many people would notice that they ended up at an HTTP connection instead of an HTTPS? I don't know many who would. The people who aren't security conscious about their router probably are the same who wouldn't notice anything about certificates, because they seem more obscure to me than router security. Yes?
Well, I mean, people may not know about security with the browsers, but certainly simply forbid you from entering certain information in pages that aren't properly secure.
OK, so the comment is that browsers could forbid you from entering secure information on websites that are not authorized. Sure, if we had a proper public key infrastructure, this could be maybe implemented in browsers. But who whitelists websites? You trust VeriSign. Okay. Well, then we have a policy debate instead of an implementation debate. But
Well, the implementations currently fail open. If something fails, the browser allows it or asks the user to say, yeah, click yes, and it works. But if it fails closed, then a lot of problems might.
okay, the comment is, what if it fails closed so that if the certificate isn't authenticated, it just doesn't let you access the site? I think that would really tick off a lot of people who use their own CAs. It would tick off a lot of people who use self-signed certificates for testing.
Those are the people who can actually put their own CA keys in their browser themselves.
Not necessarily. It's a little bit of extra work in order to get all of your clients to add a CA to their browser. My university has a CA of their own, and I have to add it to my browser to get rid of those. Do you want to accept the certificate dialogues? That ticks me off to no end. But I trust my university.
With respect to that last question, this was the argument about whatever Microsoft Wallet or whatever they had, where the problem for the fisher becomes to get somebody to add a key
Right.
to their, or a CA to their list of trusted CAs, and then you have them just as much as you did before.
Right. So for people who didn't hear that, the comment was it just moves the problem from actually just automatically allowing somebody access to convincing them to allow access, because ultimately users should have control over who they trust. So if you can phish them, then you can farm them. Okay, thank you.